All right, in this video, I'm going to discuss how you can create a report on the performance of your classification algorithm. And this is going to apply to any classification algorithm that you're running. Say it's a KNN, decision tree, random forest, gradient boosted trees, SVM, or neural networks, whatever it is, as long as you're doing classification, this particular approach would work there. So as an example, I'm going to continue working off of the file that we have been working on about the classification of iris species into 3 classes. So I will put a link to the video on which I went through all of this, and I'm going to just continue working based on that. So far, what we have done is that we've implemented a k-nearest neighbor algorithm in order to classify different species different species of iris into 3 groups which were basically setosa, versicolor, and virginica. And note that here the KNN did especially good, meaning that 100% accuracy. Anyways, I'm going to create 2 things. First, I'm going to create a confusion matrix, and then I'm also going to create a performance report for the algorithm. And to do that, the very first thing that you have to do is to import metrics from sklearn. So I'm going to insert a cell below and go ahead and type in from sklearn dot metrics import from sklearn, import metrics. And because I'm going to down the road create a classification report, I'm going to say from sklearn dot metrics import classification report. All right, and just to refresh your mind, note that we did the predictions using the KNN algorithm that we had already trained and stored the prediction in an array called y_pred. Now, using that, we can go ahead and actually create a confusion matrix. And to do that, you'll have to type in metrics dot confusion matrix. So confusion matrix is a function that's going to actually go ahead and create that confusion matrix for you, and it needs 2 inputs. The very first one is the actual classes, which are stored in ytest array, and the other one is how your model predicted the classes, which in this case, remember, we have already put the predictions in an array called ypred. So if you do this, you will okay, you will get the predictions. However, this is giving me the error because I have not run the model, so it doesn't know what ytest is. So I have to run everything from the top again. And once I do that, it actually prints this confusion matrix for me. So it is fine. And as you can see, that is 14, 24, and 12 on the diagonal and 0 everywhere else, because this was a 100% accurate machine learning algorithm in this case. So there's nothing wrong with this confusion matrix. It is technically correct. However, what I want to do is that I want to make it much more visually appealing and informative. So to do that, I'm going to use the heat map within SNS. So I go ahead and type in SNS.heat map. And basically what I want to do is that I want to use this and put a heat map on top of it. And in order to do that, first I'm going to put this in a data frame. So rather than just printing the content of confusion matrix, I'm going to put it into a data frame that I am going to again call it confusion matrix. All right, and then once I run it, then this doesn't get printed. And then I can use and say, hey, I want to create a heat map based on the values in the confusion matrix. So let's do this step by step so that you see how it works out. So this is the heat map that it generates, and it's not really good, right? Because it's the colors are not nice, and we don't have the values there. So let's improve it step by step. The very first thing that I want to do is to use a different color map, and in this particular case I'm going to use the blues color map. So once you do that, the colors change from say black and red to different shades of blue, which is much nicer. The other thing that I want to do is that I want to remove this color bar. So I go ahead and say C bar is equal to false, and let me run it again for you, and you see that that color bar is removed because it was not giving us that much of information. And then the other thing that I want to do is to actually print these values here, right? To see the number of instances, for example, that were actually 0 and were predicted to be 0. So, and to do that, you can just type in annotate, or NOT is equal to true, and then it will print the values of the confusion matrix here on your heat map, right? So far so good. Another thing that I want to do is that rather than having 0, 1, and 2, which were the classes of iris species, I want to type in the actual name of the iris species. And to do that, I can go ahead and use the X text and Y text options. So I can just type in PLT X ticks. And go ahead and type in np.arange of 3. So what does np.arange does is it's a function within numpy, and what it does is that it creates an array that is going to have 3 elements, and they are going to be arranged from 0, 1, and 2. All right. So basically, I'm referring to this 0, 1, and 2. Right. So I'm going to put ticks at 0, 1, 2 positions. However, I'm going to move them a little bit. So 0 is going to be actually here, and then 1 is going to be here, and 2 is going to be here, right? If I want them to be right where you see the ticks are right now, I have to move them to the middle. And because each of them is 1 unit, I have to move them half a unit. And then if I do that, rather than being here, the tick is going to come here, right? Exactly where I want it. That's why I'm going to say plus 0.5. And then I have to give the labels for these 3 ticks. And those are going to be Setosa, versicolor, and virginica, corresponding to the class names in this data set. All right, so that is going to create the labels on the text for the x-axis, and I just have to change it from x to y in order to have the labels for y-axis. So you see that 0, 1, and 2 is now changed to Setosa, versicolor, and virginica, both on the x and y-axis, right? And if you want to get rid of this text, you can just type in plt.show. And then it gets rid of that. Now, you can also enhance it a little bit and put a label for x and y axis using the x label command. So for x label, we actually have the predicted classes. And for y label, we have actual classes. All right, and once we do that, then you see that we have actual classes here and predicted classes here, right? Very nice. So one thing that I want to discuss here is that when you have a confusion matrix for a classification problem that has more than only 2 classes, how are you going to identify true positive, true negative, false positive, and false negative? Because in the video that I discussed in the theory, we only had a 2x2 confusion matrix, right? And it was so easy to say that, okay, this is true positive and this is true negative, and this is going to be false positive and this is going to be false negative, right? But how are you going to do that when you have more than two classes, right? How are each of these additional cells going to be considered as true positive, true negative, false positive, and false negative? Well, that is very easy. And the key thing to remember is that once you have multi-class classification problems in the confusion matrix, you have to define those four values for each class separately. All right, so let's go over this and actually do this. And in order to be able to go over this concepts a little bit easier, I'm going to create another matrix, another fake confusion matrix, and I'm just going to put the label of the cells on it, right? So this is the true confusion matrix, and what I'm going to have here is this matrix, right? That each cell is identified, cell number 1, cell number 2, cell number 3, 4, 5, 6, 7, 8, and 9, right? And I'm going to discuss how to calculate each of these values. Let's start with the simplest one. The simplest one was the true positives, right? And remember, I told you that you have to do this for each class individually. So you have to start with the Setosa class, right? What is true positive? True positive means that the number of instances that are actually positive and are also classified as positive. In other words, for Setosa, it means that the number of instances that are actually Setosa and are classified as Setosa, that is going to be equal to 14. In other words, when you look at this matrix, it's going to be the value in cell number 1, right? So that is true positive. Now, how about true negative? True negative with respect to Setosa means that it is going to be all the instances that are not Setosa and are also not classified as Setosa, right? What does it mean? It means that the classes that are actually either versicolor or virginica and are classified as something other than Setosa. So if you look at this matrix, again, the classes that are actually not Setosa, which means that they are in row 2 and row 3, right? Versicolor and virginica. However, those species that are actually versicolor and virginica should be classified as something other than Setosa. So within row 2 and 3, the first column are the ones that say the predicted class is Setosa. So anything other than that would be in cells 5, 6, 8, and 9, right? So when you look at the confusion matrix, the values for true negative will be 24 plus 0 plus 0 plus 12, right? In other words, it's all the instances that are actually not Setosa and are also classified as anything other than Setosa. How about false negatives? How are we going to define false negatives? Again, with respect to Setosa, false negative means that something that is actually Setosa but is incorrectly predicted as something other than Setosa. So that is going to be whatever is in this cell and this cell, specifically cell number 2 and 3, together are going to be false negatives. Why? Because they are actually, Setosa, but are predicted as anything other than Setosa. So this is going to be our false negatives. Now, if we want to find false positives, again, we have to use the same logic. What does false positive mean? It means that something that is not Setosa, but is incorrectly classified as Setosa. So when we look at here, the predicted classes for Setosa are in this column. Okay, so these are the instances that are predicted as Setosa, right? We want the ones that are incorrect. We want the ones that are anything other than Setosa, which is these two cells, right? So if you look at here, it's going to be cell number 4 and 7. Why? Because they are predicted to be Setosa. However, that prediction is incorrect. And in other words, that is a false positive. So cell number 4 plus cell number 7 is going to represent false positives for us. So the last thing that I want to do here is to create a classification report. And to do that, you can just type in classification underscore report. Again, this is a function that we just imported up here. Classification report is a part of the scikit-learn metrics library. So classification report creates the classification report for us. And again, just like confusion matrix, it needs the two components or inputs, y-test and y-pret. And the other thing that I want to give it is to put the dictionary on it. So I just type in output underscore dict is equal to true. And once you run it, you get something like this. It's not really good. What I want to do is that I'm first going to put it into a data frame. So I just say report is equal to this. And once I have done it, I'm going to transpose it. So I just type in final report is equal to my classification report. And we have to use pandas data frame here for transposing. So we are going to transpose this. And then once we have that, we can say print final report. And we will have something like this, which is perfect, right? So here, remember that you have class 0, 1, and 2 corresponding to sedosa, versicolor, and virginica. And then you have reported precision, recall, F1 score, and support for each of the classes. In addition to that, you'll have accuracy, macro average, and weighted average for each class as well. Sorry, these are not for each class, these are overall, right? So let's go over them very briefly and discuss what they mean. The first one is precision, which, as we discussed in the previous video, is defined as the number of true positives divided by the sum of true positives and false positive examples, right? So in the example that we were working in the previous video, which was about cats and dogs, the precision is basically describing, say, of all the images that were predicted to be cats, how many are actually cats? In other words, of all the instances where your machine learning predicted a positive, how many are actually positive? And that is with regards to the 0 class, which was the sedosa class, right? So basically here, there are 14 instances that are predicted to be positive. There are 14 instances that are predicted to be sedosa. How many of them are correct? All of them are correct because that is all that the machine learning has predicted, right? That's why the precision is of 1 for the class of sedosa. And the same goes for class 1 and 2, right? So in other words, of all the predictions, which is the sum of the cells 1, 4, and 7 for sedosa, right? Of all the ones that you predicted to be sedosa, how correct you were, right? In what percentage of instances you were correct, and that is going to be 100% for precision. Recall, on the other hand, is defined as the number of true positives divided by the sum of the true positives and false negatives. In other words, it's asking, out of all the real true positives that are existing in the data, how many could you find, right? So basically, when we look at here, the actual classes for sedosa, the cells number 1, 2, and 3 represents the sum of these cells represent the total number of real Setosa flowers that we have. And recall is asking what percentage of these we could actually identify, which is going to be 1 divided by 1 plus 2 plus 3 here, right? And again, in this case, it is going to be 100% because it's going to be 14 out of 14 plus 0 plus 0, right? The other thing is the F1 score. F1 score is an average of precision and recall. And it's a really good metric when the data set that you have is imbalanced, meaning that there are more instances of one class than the other, right? This is not the case here, but if it was, the accuracy may not be a good metric, and therefore a better metric would be an F1 score. Finally, support indicates the number of instances within each class in the data set, regardless of how well you predicted them. So it basically says that there are 14 of class 0, 24 of class 1, and 2 of class, and 12 of class 2, right? So basically, how many instances of each class exists in your testing data set. Similarly, you have accuracy calculated for each class, as we've described before in the video. That is going to be the ratio of true positives and true negatives divided by all the other classes together combined. So divided by true positive, true negative, false positive, and false negative. So the macro average is the weighted average of precision, recall, and F1 score for each class, and they are weighted by the number of instances within each class, right? So the weighted average is going to be the precision, recall, and F1 score average weighted by the number of instances within each class.